watch is off.
All right. It looks like we are at 2 o'clock. Hello, everyone. Can you hear me? I hope you can. Welcome, Explore UT. We are coming to you from University of Texas at Austin. We are in front of the UT Tower. Hopefully the view is coming through nice and clear. We got a beautiful day. It's not raining. It's just right temperature, so great day to fly a drone. We have several things to show you today, but first, introductions. My name is Robert Stepnoski, professor here at the School of Architecture. And to my right, I have...
I'm Doug Shea. I'm a graduate student here at UTSOA.
And to my left?
I'm Sydney Burt, also an MArch student here.
All right, welcome. All right, moving right along. Next step is multimedia presentation for you. Let me scroll up and left. Which we will show
I cannot
photogrammetry, 3D point cloud models, 3D models, architectural drawings, how our models are made using drones, 3D laser scanners, and DSLR cameras. And last but not least, smartphones, which some of us may have right now. We're going to take you step by step through how we do this, the tools that we use, and then about halfway through the presentation, we will actually fly 2 different versions of drone flights and allow you to see that first person. First flight will be mapping as if we're building a model of the terrain right behind us, and then second will be point of view so you can actually see what the drone sees up in the sky. Okay. Next step here is to go through our multimedia presentation to give you an idea of what this is, the drawings that we make, the models that we make, and the gear that we use. We'll talk about what photogrammetry is, what point clouds are, project examples from right here in town, on campus, and around the Austin area. Then the art of the point cloud, which are beautiful drawings, which are kind of a byproduct of how the drone captures an area. And then finally, the drone flight by the tower.
So I'm going to start by giving a quick introduction into how this technology works. Basically, by using a collection of photographs, you're able to compare points in common through those photographs, and using the parallax effect, which is the effect in which further objects move a different distance than nearer objects. You can triangulate the location of those points and create a point cloud and then a model off of that. These are a couple examples. On the left, we have an aerial gridded flight, which is where you have a UAV or a drone flying above a structure and taking multiple photographs, again, finding those points in common and using those to construct a model. And then on the right, we have terrestrial capture, which might be something that you just do with your phone or with the DSLR camera. And again, taking a bunch of photographs, the software is taking and finding points in common throughout all those photographs and using those to create these 3-dimensional models that you can see right here. And again, this is not that complex of a technology. A lot of it exists kind of on the computer in terms of finding those points. So really you can use anything as simple as the smartphone that you might be watching this on right now. Again, you're kind of looking to have those overlaps in the photos so that it can find those points in common. So the good rule of thumb is about a 1/3 translation so that you have 2/3 of overlap within each photo. This is an example of the Seaholm Intake Building here in Austin. Again, you can kind of see the way that the photos are wrapping all around the interior of that space, looking up, looking down. And then the software piece is finding those points in common and creating this virtual version of that real building. This is kind of more relating it to what we're going to be showing you today with the aerial. So on the right, we have Pix4D, which is the software piece that we use to do this type of operation. It connects to a lot of consumer grade drones, and then you can fly these different types of missions where it's flying over, automatically taking these photos. It knows where it is in 3-dimensional space, and then those photos are taken and processed into the models. So the left, we have a double grid where it's kind of going back and forth in one direction, back and forth in the other, taking photos. And then the second one, we have more of a circular orbital flight where it's taking and looking at one specific structure and trying to kind of get all of the elements of that structure. And the way that the software works is that it can either use these more manual control points, which we have some of these laid out behind us. And you place those down as an easy object for the software to kind of grab onto. And then it also finds other points in common between the photos. And then the results of these are obviously kind of point clouds, but then these can kind of be turned into surface models that are looking at the surfaces of any kind of object in the area that you're trying to map, or these digital terrain models, which are just looking at the actual ground beneath it and can kind of become the basis of maybe adding a new structure on that site. Today and always we'll be operating under the FAA guidances for UAVs, which you can kind of read some of these here. And then we're going to go ahead and transition over to Sydney, and she's going to give a little bit of examples of projects that have been done using this method.
Yeah, so Doug and I both took this class with Rob that goes over all of this technology. So I was able to take it 2 summers ago when everything was in person. So we went to sites both on campus and around Austin, starting with the Goldsmith Courtyard, which Rob had already made a digital model of. Showing a point cloud, processing in Autodesk Recap, color mapping. We also went to the LBJ library on campus, which was a cool site. We were focused around the fountain and also getting certain vantage points of the library. So this shows the capabilities of making models that you can cut through of the site. We also went to the Mueller Tower over in Mueller, and we tried to get photographs both inside and outside, showing the point cloud, some animation. Showing the processing. Then we ended by going to the Ladybird Johnson Wildflower Center, which was a really cool project for just giving, it was a building with more texture and like an unconventional shape, so it was a challenge to document. Just showing all the different documentation that we can get from this type of process. We ended up with some really beautiful images and drawings that that you can take into architecture studio projects. Do you want to add anything, Rob?
What you're seeing here are architectural drawings, sections, and 3D models generated directly from the 3D point cloud model. Here we're slicing through floor plates to make it look like that 3D point cloud is an actual drawing. And that brings us to a segue to the art of the point cloud. The art of the point cloud happens to be a byproduct of what that model provides you. What you're seeing here is something you would not necessarily see in real life. So if you were in front of that tower, you could not see this model. This model is generated by scanning the interior surfaces and then creating a self-standing model with color mapped to it. These are vignettes with small sections of the model itself.
Looks like Rob and the crew got booted. Maybe they lost their Wi-Fi connection. So let's just on. Oh, he's back.
I think his internet went down. What are the blue lines?
I think you're right. The internet did have a little bit of a hiccup.
Sorry about that.
But I'm pretty sure we might be back now.
Yeah, I think we're good.
We have proof right over here that we are back. That's good. Okay. Right on back to our presentation. What you see here is the interior of that tower, but seeing it from the drone's eye view.
Mister?
Yeah.
I'm sorry if I said your name wrong. What are those, in those pictures, what are the blue lines?
The blue lines. In
the pictures you showed us before, the the ones that look like little pyramids around? When
It's in the bottom left-hand corner.
Lines for,
Sorry, go ahead, Sydney. I'm sorry, I can't. Can you say it again? This
She was
one here?
asking what is that blue, red, and green lines on the bottom left-hand corner?
Oh, the blue, green, and red lines.
It's the Y, X, and Z
Oh, you're
axis.
absolutely correct. It's the X, Y, and Z axes.
Axis.
So you're totally correct. So that whenever it's creating these points, every single dot has an X, Y, and Z position. And so that's how they orient themselves to each other. And what you're seeing right now is the result of that. But yeah, you're absolutely right that it's the X, Y, and Z.
Okay,
Perfect.
perfect question. Yeah, get that mouse. Somebody else. Okay, what we see here are plan views of that 3D point cloud model and make it look like an architectural drawing set. What you see here is the point cloud model with a slice going through the building. It's called this architectural section. This is another section. You can see a different part of the tower itself and on the interior, as well as the lower chamber. These are mesh or solid models of that interior space to make it look like a self-standing building. This is a single part made out of a clay model or clay texture, just another way to study the interior space itself. What you see here is the honors quad right here on campus. That's a very large space, needed to be captured with a 3D laser scanner and drone. This way we can experience the space itself and be under the tree canopy virtually. And believe it or not, we put these models into our VR goggles. What you see here is color mapped to a train track or train trestle to understand where the single point perspective goes. Here's a mini model of Stonehenge with color mapped to the 3D point cloud model itself. That right there is a large oak tree here in town, scanned with a laser scanner and drone and combined to give you a black and white, beautiful 3D point cloud model. This one's interesting where we scanned the surface and had people walking by and capture them in time and then assign points to them, and you have an instant model kind of frozen in time. Some of us may recognize this. This is Pac-Man mapped to a single block in Pompeii. What you're seeing here is a mountain range scanned by a drone and then Pac-Man, that's right. And then color mapped to the points themselves so you get to see the undulating terrain of the mountain. What you're seeing here is color mapped to elevation, whereas blue is low and red is high, but that gives you a good idea of how that terrain gradates as it goes up the mountainside. Okay. That is our multimedia presentation part of this. You're gonna hear the bell in the background. Next step is to show you how drone flight happens. So please hold.
Yeah, I'm gonna take over the screen share. Does anybody have any questions? Patricia, I see that your hand is up. I'm not sure if your question was answered.
Yes, my question was answered.
Perfect, glad to hear it. Give me 1 second to switch to my phone. Share my screen.
Sorry.
No, you're fine. So let's see. Boom, boom. Can everybody see that okay?
Yep.
So yeah, what we're looking at right now is the Pix4D interface on the phone. So this is on my phone right now. And what it's doing is I'm setting up a mission in which I can map out. Hello? Somebody have a question?
This looks like Google Maps.
It is. So the underlay is Google Maps, but this green box right here is something that I'm laying on top of that map, kind of letting it know where I want for it to take photos. And then I can adjust
So it's gonna
how
like
much.
go all around the
Rolling the drone to take photos around that certain area of campus.
Yeah, so we're right in front of the tower right now. We're just going to be flying right over this area. It's going to be taking a whole bunch of photos, and then we could also take those and process them into a model. And if you see in the top right here, there's also the live view of the drone that's right behind me. So I'm actually going to go ahead, make sure that everything's looking right. On the left here, we can adjust the altitude. So we're going to be at 150 feet. We see at the bottom here, it's going to take about 4 minutes for the job to complete. And then once we're satisfied with anything, we can just go ahead and hit start.
Can we see it?
Yeah,
Or are
we're going to
we
be
doing
showing
it?
it the whole time. So it's sending the mission to the drone, and we're going to take off right now.
It's doing it. Can't log in. Unbelievable, man. It's good. Yeah. I'm just trying to log into Zoom and I can't. You got the meeting ID perhaps?
For some reason, it looks like an actual person just flying up there.
Yeah, it does, because there's a nice
pictures.
camera right there. We could wave to it.
Yeah, I can't log into Zoom. Unbelievable. I'm the host.
So yeah, what it's doing right now is it's flying that path, and it's taking photos every once in a while in order to create that model.
Do you need the meeting ID?
I got it actually.
Does anybody have any questions while this is going?
Where is this on the campus?
Can you say that again? I didn't hear you that clearly.
Where is this drone on the campus?
So we are right by the tower.
Keep watching it, dude.
So we're actually kind of right in the center of the original 40 acres of campus.
How do you decide how high you need to fly it?
You can't fly over 400 feet, so you need to be in the proper range depending on if you're flying around a building, above a building. So it'll depend on every particular flight, but never over 400 feet.
Never over a crowd, never over a stadium. If you are out of line of sight, which means if you cannot see that drone anymore, you have to have a visual observer with you. What you see there is the drone is actually mapping the area. And each picture you see is a picture it takes every so often. The camera itself is facing straight down, so it's mapping the terrain. And once it's done, it'll come back home and sit on that orange and black H behind us. That's a pretty good view right there.
Take it back.
Okay. So let me try to share my screen. It's coming home. Want to give up your screen?
So can you bring it home anytime you want, and if you decide to abort the mission?
Right now, yes. If you have to abort the mission for some reason, you just move the sticks on the controller and it'll come home, but you have to fly it manually. What's happening right now is it's flying autonomously or on its own through a pre-programmed drone flight. So Doug is bringing it home right now.
So basically, it's just like a kid one, but this one has cameras on it, and
right.
it's more
It's on autopilot.
able to go higher, and for it to be more
Yeah, bring it home manually.
much more easier to fly.
That little drone has a 4K camera on it with the triple axis gimbal, which is why it's so smooth. Doug just brought it home and is landing it right now, successfully.
Yay.
Hooray! Next step, I'm going to free fly the big drone, and hopefully you can see what it sees. All right, let's do the share screen. Yeah, I'm gonna kill yours. I don't have to kill yours.
Do you want a microphone on?
Well,
Oh, I think you just canceled it. Oh, no, there we go. You can go over to, oops, sorry, wherever you need to be.
sure.
Yep, we just see the Zoom screen.
Okay.
Perfect.
All right. There's a lot of questions coming through. So
Awesome.
It's pretty good.
Yeah, does anybody have any other questions? I saw there was a question, I think, about 4D costed. If you were to purchase it for like a business or to use for like commercial purposes, it would be probably in the thousands of dollars. But we were provided the licenses for free because we're using it for school. So it doesn't cost anybody anything for if you were a student here and being able to use it. Stacy, it looks like you have your hand raised. Do you have a question?
Why are drones important?
I think they're important because they're able to map or take dimensions of very large areas very quickly. Sometimes if you're trying to build a building on a large piece of land and you need to kind of know the way, the specific shape of the ground, it can be really tedious to do that by hand because you'd have to basically walk throughout the site in order to find the elevations or the shapes of the ground in kind of all of those different areas.
Okay, looks good.
But when using a drone, it can do, I mean, square miles.
The home point has been updated. Please check it on the map.
So we're taking off right now. We're gonna be looking at the tower. Yeah, but it can do large areas very quickly. And also because of the GPS, you know almost exactly where that drone is in that XYZ coordinates of the real world. So it's very easy to then take that information and create a model out of it. Does that answer your question?
Rob,
Perfect.
Yeah.
Great.
Question.
Go ahead.
My question is that, you know how the drone can go up? Can it also go underground?
So they're actually, so the drone uses GPS, kind of the same as if you were on Google Maps on your phone, kind of being able to navigate around town. It uses that same technology in order to kind of keep itself stable. But I have seen projects where people will use these drones, same sort of technology, and actually kind of go into mines or underground caves and stuff and map out those conditions as well. So those ones don't use GPS because when you're underground, you're not able to get a GPS signal, but you can still use them underground. Obviously, I don't know if there's like underground.
Sir, he needs to focus right now.
Sorry. Is there any other questions? Did that answer your question?
I was also gonna say, how big is the campus?
How big is the campus? That's a good question. 400 acres? Wow.
I thought it was 40.
Like how many feet is an acre?
Ooh, that's a good question. Oh, 4 acres. 40 acres. No, the 40 acres is the original campus. So I think it's actually expanded a little bit beyond that. So we are in the 40 acres right now because it's all the older buildings and campus. So if you look on the screen, a lot of those buildings with the red roofs are part of that original 40 acres of campus. But as it kind of spreads out, that's a little bit larger. I don't know the exact number. But probably to walk from end to end of campus would take 20 minutes.
At least half an hour.
Really, maybe 30 minutes. So depending I don't know how fast you walk. Oh, 431 acres. There you go. Thank you, Justin.
An acre is about 43,560 feet.
Thank you.
I
Great.
did not know that because I'm only in
I'm just wondering, can it work off grid?
Bring it down and just.
Can it work off grid? Is that what the question
Yeah.
was? So like no GPS, is that what you're saying?
Like, does a GPS work if it doesn't like have any cell service?
Yeah, so GPS is actually kind of a different technology than cell service is. So cell service is sending data. What GPS is it's satellites that are in space, and you send a signal.
The
to
GPS of
satellite.
the, what I mean is the GPS of the drone. Can it
Yes,
still work if it's offline?
Correct. Yeah, you don't need an internet connection in order to pilot the drone. Correct.
Did I notice up there it has like an internet connection?
Yeah, so kind of on the top right, you see it says 5.8G. That's the connection between the drone and the controller. And then the next one is the battery of the drone, or sorry, the connection of the controller. The next one is the signal strength, and then it's GPS. Perfect. And then it's the GPS strength. So you see it says 12. It's connected to 12 different satellites, and it's using those to kind of figure out where exactly it is in space. So you don't need a data connection, but you do pretty much anywhere in the world you can get a GPS connection. So
okay.
Yeah. Was there any more questions?
I have a question.
Is it Iker?
Yes.
Go ahead.
Do you control it or does it go by itself?
So what I was showing where it had kind of that Google Maps or that Google Earth underlay, that was autonomous. So I just said, I want you to fly here. I want you to take this many photos. I want them to overlap in this way. And then it goes up, it takes the photos, it follows that path, and then it comes back down and lands. What Rob was just doing, he was flying it kind of with something that looks like an Xbox controller, a big Xbox controller. And so then that's how you control
That's the remote. I've seen multiple of those. You could hook it up to like an iPad or a phone.
Yep. So this one's hooked up just to a phone right now, but yeah, you can hook it up to an iPad and it'll feed whatever the drone sees, you'll be able to see on that iPad. That's right. Larissa?
How high, what's the highest that a drone could go?
So according to the FAA, which is the same agency that controls like airplanes, the highest you can go is 400 feet above the ground. So that's the max allowable height. How high were you?
I was just under 300 feet.
Yeah, so we still had another 100 feet above where Rob was just flying. So yeah, they can go up pretty high. But of course, they control it so that drones aren't crashing into airplanes and stuff like that. So, Patricia, do you have another question?
Well, it's not a question. It's because my cousin actually goes to this university.
Mm-hmm.
That's
That's cool. Yeah. Very cool. Do you think you might want to go to UT one day?
I don't know.
Yeah, I think you've got time. I think you've got time to figure that out. Very cool. Are there any other questions? I think we are almost at the end of our time, if not exactly there. So any last questions for any of us?
Are you able to make if you have a drone, are you able to just put a certain location and it'll just go there without a control?
So the controller is how it's communicating. It's got these big antenna on it. So you do need the controller in order to kind of send those instructions to the drone. But yeah, you could say, I want you to go here, and it'll fly itself over there. They're actually pretty easy to fly. If you don't push anything on the controller, it kind of just hovers there right in space. So they're very stable. It's not like flying like a plane or anything like that. They just kind of sit there.
That sounds pretty cool.
Yeah.
I can relate that to Minecraft. Is that there's this mechanic called elytras, and so you could use them, but if you stay too much in place, you will slowly descend.
Oh, interesting. Oh, I guess it is kind of like that. So this one, it won't descend. You don't have to keep yourself up. You kind of just, if you want to go higher, you tell it to go higher. If you want to go lower, you tell it to go lower and everything. But if you don't push anything, it'll just sit there. But yeah, it kind of sounds like that, doesn't it? Any last questions?
I have one more question.
Go ahead.
Okay, time for 2 more.
Does it ever like glitch and go to another place?
I mean, they can sometimes glitch. If something goes wrong, usually what they'll do is they'll, like, let's say the controller breaks in the middle of a flight. It'll say, or it'll sit there for a bit. It'll recognize that the controller is no longer being used, and it'll fly back and land where it started from. So it won't have any kind of issues. It'll kind of just take it back to where it started so that it doesn't crash into anything and it doesn't just fall out of the sky. So they're actually pretty safe. They're kind of smart how they're designed. One more. Who wants the last question? Matthew.
That what happens when it dies? Will it stay be floating, or will it just fall straight down to the ground?
So
and what happens when the controller dies?
So if the controller dies, it'll go home, kind of like how I was saying. If the drone recognizes that its battery is so low, it'll try to just let itself down slowly. I don't know. I bet that's like the last case scenario. I think worst case scenario is the battery runs out and it falls out of the sky. It'll do everything it can to avoid something like that. So. Yeah.
Well, technically, how you avoid that is you tell the drone that once the battery is within 15% left, it comes home. It also is smart enough to know that if it's too far away from you, that it's not going to make it home. It'll let you know that it doesn't have enough battery left. So it's super smart.
So you could just go to it before it dies.
Right.
Yep.
My question also contains to this question. It's because that's how many minutes is 1% worth? Is it less than a minute?
It depends because they're keeping themselves, trying to keep it in a certain point in space. If it's really windy, it's trying to resist that, right? It's trying to kind of go in the opposite direction of the wind. So it's using up a lot more battery in that case versus if there's no wind whatsoever and it can kind of just...
No, like just a normal day.
No, like if it's like using more energy, then it's like taking away more battery?
Exactly, yeah. So 1% could be 10 seconds, 1% could be 30 seconds. It really kind of depends on what the drone's having to deal with, yeah. Typically, I think they last about 25 to 30 minutes on 100%, which would make 1% is 30 seconds. Is that right? No, is one. I'm not going to try and do the math on that. I'll leave that to you guys to figure out. If 100% is 30 minutes, how much is 1%? We don't have to do that right now. Any more questions?
I have my last question.
Okay, all right, I'm ready for it.
If you're flying it and like it's about to rain, does it warn you?
It probably will not know that it's about to rain. Hopefully you would. Yeah, they're not waterproof, so you'd have to kind of be looking at the sky and see if there's dark clouds and stuff, because yeah, there is a lot of like preparation that goes into flying a drone in terms of taking into account the weather. If you're close to an airport, there might be a different height limit depending on how close you are. You have to get sometimes FAA clearance depending how close you are to an airport. So there's kind of a lot of systems in place to make sure that flying a drone is safe, both for you, for the drone, and then for anybody that might be underneath the drone. All right, I think that's it. I think that's enough. One last question. So thank you guys so much for joining us. I hope you've enjoyed. I didn't hear if that was a question, but I appreciate everybody stopping in. Enjoy the rest of your Explore UT courses. Hopefully next year we'll get to see you all in person. But for now, goodbye, everyone.
Thanks, everyone.
Bye.
Bye.